Good afternoon everyone. An equation means nothing to me unless it expresses the thought of God. This is the famous quote of Srinivasa Ramanujan. Seeing the divine blessings of the Almighty and His Holiness Sri Vishwanath Swamiji, I, Reverend Sharon Wallace, welcome you all on behalf of the Pilgrim Regional Science Center, PRSC, in association with the Department of Mathematics and IST Faculty Chapter of Sri Madhva Institute of Technology and Management, Bantakal, for today's innovative talk, Mathematics Day Experience. On account of National Mathematics Day to commemorate 133rd birthday of the great Indian mathematician Sri Srinivasa Ramanujan. On this occasion, we have with us Dr. Raghavendra as a business person, our principal Dr. Tiruneshwar Bhatt, Vice Principal Dr. Ganesh Aital, Dr. Vasudeva, Dean Research and Consultancy, Dr. Subhashini Rao, Dean Quality Assurance, heads of the departments, faculty and staff members, and students. Also, around 400 science and maths teachers of Dakshina Kannada and Udupi district will be watching this live on YouTube. Once again, I welcome you all. Now I request Dr. Manipura Testimony, HOD of Mathematics, to formally welcome today's resource person, Dr. Raghavendra A. Thank you, Madam. Srinivasa Ramanujan was one of India's greatest mathematical geniuses. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. Now I request our principal, Dr. Tiruneshwar Bhatt, to provide a brief introduction about today's program.
Good afternoon. Esteemed guests of today's celebration, Deans, HODs, Vice Principal, faculty members, ladies and gentlemen. As you all know, we are celebrating 133rd birthday of great Indian mathematician Sri Srinivasa Ramanujan on this day. First lived for about 33 years, but his achievements are marvelous. I think the guest and Dean Research and Consultancy will elaborate all those details during their presentations. We are remembering his contribution on this day, and mainly we are celebrating to pass the message or to encourage the young students and young mathematicians to follow the path of Sri Srinivasa Ramanujan. We have joined hands with Pilgrim Regional Science Center, Mangalore, to celebrate this program jointly, that is the National Mathematics Day. And my sincere thanks to Dr. K.V. Rao, who is the Director of Pilgrim Regional Science Center, Mangalore, for associating with us in this important program. And this program is broadcasted in two districts, Dakshina Kannada and Udupi district, and there the faculty members, both mathematics and science faculty members, they are watching this program through webinar. So live streaming of the webinar is also arranged for the benefit of such faculty members. This is a welcome program to all teachers to get related to Sri Madhva Institute of Technology and Management. We have a lot more ideas to reach infinite through all our innovation and ideation centers. I request all the staff members to feel free to visit our campus and make use of the resources to your students' development. I also request on this occasion the Director of Electrical and Mineral Science Center, Dr. K.V. Rao, to involve us and use our expertise in innovation and incubation activities at your center. We have conducted several workshops at various high schools and PU colleges as institutions of social responsibility and supported learning of large number of those students through academic and lab initiatives. And our students have worked closely with such schools and the children to carry out various projects and learning through these projects. So I appeal once again all of you to get associated with the same Institute of Technology and Management and experience your learning. Have a great day. Thank you.
Thank you, sir, for sharing the information and providing inputs regarding the significance of the day. Now I request Dr. Vasudeva, Dean Research and Consultancy, to deliver the introductory session on the man who knew infinity, Srinivasa Ramanujan. Over to you, sir.
Respected Chief Guest of the day, Dr. Raghavendra, and we are colleagues in Ramanujan Mathematical Society. Beloved Principal, Vice Principal, Deans, HODs, faculty members, and dear students, also the teachers of Udupi University and Kannada districts who are watching this particular program through YouTube Live. It is a great pleasure to talk about Srinivasa Ramanujan. Of course, yesterday Ranjana madam asked me, sir, prepare I can't. Actually, Srinivasa Ramanujan madam ಮಾತಾಡಲಿಕ್ಕೆ ಪ್ರಿಪೇರ್ ಆಗಿರೋದಿಲ್ಲ. ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಗಳಿಗೆ ಅದಕ್ಕೆ ಡಿಫರೆನ್ಸ್ ಅದೆಲ್ಲರೂ ಅದಕ್ಕೆ ಇದೆ. ಅವರ ಶ್ರೀಮಂತಿಯ ಬಗ್ಗೆ ನಾವು ಮಾತಾಡಿದರೆ ಹೇಗೆ ಅವರು ಅದಕ್ಕೆ ಮಾಡಬೇಕು ಅಂತಿಲ್ಲ, ಕೊಂಡು ಮಾಡಬೇಕು ಅಂತಿಲ್ಲ, ಬಿಡುಗಡೆ ಸಾಕು ಅಂತ. ಹಾಗೆ ರಾಮಾನುಜನ ಬಗ್ಗೆ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕು ಅಂತಿಲ್ಲ, ನೆನಪರ ಬಗ್ಗೆ ಹೇಳಿಬಿಟ್ರೆ ಸಾಕು, ಒಂದು ಗಂಟೆ ಮಾತಾಡ್ಬೋದು ಅಷ್ಟಿದೆ. 32 ವರ್ಷ ಬದುಕಿದವರು, just lived for 32 years, but his achievements, his accomplishments in mathematics, of course, infinite, of course. ಅವರಿಗೆ ಹೇಳಿದ ಅವರ ಹೆಸರಲ್ಲೊಂದು ಫಿಲ್ಮ್ ಬಂತು, ದ ಮ್ಯಾನ್ ಹೂ ನ್ಯೂ ಇನ್ಫಿನಿಟಿ ಅಂತ. ಅಫ್ಕೋರ್ಸ್ ಅವರ ಜೀವನ ಚಿಂತೆಯ ಟೈಟಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಂಖ್ಯೆಯ ಬಗ್ಗೆ ಯಾರು ಮಾತಾಡ್ತಾನೋ ಅವರ ಆನಂದದ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ದಾನೆ ಅಂತ ಅರ್ಥ. I think every number was special for him. Let me go 2 points how he used to relate numbers to real life. Of course, he was in of course, you know that he died very early due to some illness, and he was in the bed, and his good old friend G.H. Hardy came to visit him. And of course, when two mathematicians meet each other, they talk only mathematics. And of course, how are you, etc. It's simply customary or casual thing. But Hardy told, see Ramanujan, I came by a taxi. The number was very, it is very ordinary, 1729. Nothing is there in that number. Ramanujan told that, who told? It is not ordinary smallest number in which you can write it as sum of two cubes in two different ways. 12 cube plus 1 cube, 1728 plus 1, and another way is 10 cube plus 9 cube, 1000 plus 729. Hardy was spellbound. This fellow, suffering from illness, but numbers and their characteristics, definitely. And another, of course, we cannot talk about his accomplishments and achievements in number theory. Why? Because to understand it we require one day. I think he has written more than 3,900 equations. Madam told about infinite series, analytic number theory, lot of results. And G.H. Hardy told that, of course, mathematicians have to prove it. Unless it is proved, mathematicians don't agree anything to be proved. He told that they must be true. Why? Others cannot imagine that such a result exists. That is the capability of Ramanujan. I think his equations, of course, equation we write a plus b square is equal to a square plus b square plus 2ab. Our level reaches there. I think his equations go to 2-3 lines. You have to see his notes, lecture notes, last notes he used to say. Lot of equations. I told you 3,900 plus results in 32 years. If he had been there for 90 plus years, I think all number theory would have been over. No more research possible. Believe it or not, based on his equations and results, of course almost all are unproved. Many theses are coming based on his results and equations. Lot of people are working on his results, that is his capability. I think one incident I can tell you, again, how he plays with the numbers. Somebody asked him, why don't you have close friends? He told that close friends must be the numbers like 220 and 284. Of course, such pairs are called amicable numbers. ಸೌಹಾರ್ದ ಸಂಖ್ಯೆಗಳು. ಅಂದರೆ ಒಂದು ನಂಬರ್ ಇಲ್ಲದಿದ್ದರೆ ಆ ನಂಬರ್ ಅನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು. ಸ್ಪೆಷಾಲಿಟಿ ಹೇಳ್ತೇನೆ. 223 ಎಲ್ಲ ಡಿವೈಸರ್ಸ್ ಅನ್ನು ಪಟ್ಟಿ ಮಾಡಿ, ಅಂದರೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ರಿಮೈಂಡರ್ 0 ಬರಬೇಕು. 220 1 2 4 5 10 11 20 22 44 55 110 ಮತ್ತೆ 220. ಇದು these are the proper divisors of the number 220. except 220 ಉಳಿದದನ್ನು ಆಡ್ ಮಾಡಿ 110 55 ಎಲ್ಲ ಆಡ್ ಮಾಡಿದಾಗ 284 ಬರ್ತದೆ. ಅದೇ 284 ಇದ್ದು ಪ್ರಾಪರ್ ಡಿವೈಸರ್ಸ್ 1 2 4 71 142 ಇಷ್ಟೇ ಇಡು. ಅದನ್ನು ಆಡ್ ಮಾಡಿ ಸಮ್ ವಿಲ್ ಬಿ 220. ನಂಬರ್ಸ್ ಕಾಂಪ್ಲಿಮೆಂಟ್ ಈಚ್ ಅದರ್. ಇದು 220 ಇಲ್ವಾ, 284 ಎಲ್ಲ ಡಿವೈಸರ್ಸ್ ಅನ್ನು ಸೇರಿ ಒಟ್ಟು ಮಾಡಿ 220 ಸಿಗ್ತದೆ. 284 ಇಲ್ವಾ, 220 ಡಿವೈಸರ್ಸ್ ಅನ್ನೆಲ್ಲ ಒಟ್ಟು ಮಾಡಿ ಅದನ್ನು ಆಡ್ ಮಾಡಿ 284 ಸಿಗ್ತದೆ. ಈ ತರಹದಲ್ಲಿ ಕಾಂಪ್ಲಿಮೆಂಟರಿ ಆಗಿರಬೇಕು. ದಟ್ ಈಸ್ ಕ್ಲೋಸ್ ಫ್ರೆಂಡ್ಸ್. ಆ ತರದ ನಂಬರ್ ನನಗೆ ಸಿಗ್ಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರಂತೆ. ವೆರಿ ಸಿಂಪಲ್ ಐಡಿಯಾಸ್ ಲೈಕ್ ಅದನ್ನೇ ಮೇಡಮ್ ಫಸ್ಟ್ ಸೆಂಟೆನ್ಸ್ ಅಲ್ಲೇ ಹೇಳಿದ್ರು. ಒಂದು ಇಕ್ವೇಶನ್ ದೇವರ ಅಸ್ತಿತ್ವವನ್ನು ಹೇಳುವುದಿಲ್ಲ ಅಂತಾದ್ರೆ ಅದು ಇಕ್ವೇಶನ್ನೇ ಅಲ್ಲ ಅಂತ ಹೇಳುವ ಒಂದು ಬೋಲ್ಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ಶ್ರೀನಿವಾಸ ರಾಮಾನುಜನ್ ಕೊಡ್ತಾರೆ. ಹೆಚ್ ಅವರು ತನ್ನ ನನಗೆ ಯಾವ ತರಹದಲ್ಲಿ ರಿಸಲ್ಟ್ ಬರ್ತಾ ಇತ್ತು ಅಂತ ಕೇಳಿದ್ರೆ, ರಾತ್ರಿ ನಾಮಗಿರಿ ದೇವಿ ನನ್ನ ಕನಸಿನಲ್ಲಿ ಬರ್ತಾ ಇದ್ಲು. ಬರ್ತಾ ಇರುವಾಗ ಅವರು ತೊಡಗಿಸುವ ಕೆಲವು ವೇವುಗಳಿಂದ ನನಗೆ ಇಕ್ವೇಶನ್ಗಳು ಹೊಳೆಯುತ್ತಿದ್ದು ಅಂತ ಹೇಳ್ತಿದ್ದಂತೆ. ಅವರೊಟ್ಟಿಗೆ ಕಂಪೇರ್ ಮಾಡಲಿಕ್ಕೆ ನಮಗೆ ಖಂಡಿತ ಸಾಧ್ಯ ಇಲ್ಲ. ಆದರೆ ಒಂದು ವಿಷಯದಲ್ಲಿ ನಾನು ಕಂಪೇರ್ ಮಾಡ್ತೇನೆ. ಅವರಿಗೆ ಆಕ್ಸ್ಫರ್ಡ್ ವಿಶ್ವವಿದ್ಯಾನಿಲಯಕ್ಕೆ ಇಂಗ್ಲೆಂಡಿಗೆ ಕರೆ ಬಂತು. GH ಹಾರ್ಡಿ ಪ್ರಯತ್ನ ಪಟ್ಟು ಎಂತಾದರೂ ಮಾಡಿ ಇವರನ್ನು ಅಲ್ಲಿಗೆ ಕರೆಸಿಕೊಳ್ಬೇಕು, ಇವರೊಟ್ಟಿಗೆ ಸಂಶೋಧನೆ ಮಾಡಬೇಕು ಅಂತ. ಆವಾಗ ಶುದ್ಧ ಸಂಪ್ರದಾಯಸ್ಥ ಬ್ರಾಹ್ಮಣರವರು, ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಫಾರಿನಲ್ಲಿ ಏನು ಕೊಡ್ತಾರೋ ಯಾವುದ್ರಲ್ಲಿ ಯಾವುದು ಉಂಟು ಗೊತ್ತಿಲ್ಲ. ನಾನು ಆಶ್ರಯದಲ್ಲಿ ಹೋಗಿದ್ದಾಗ ನಾನು ವೆಜ್ ಅಂತ ಹೇಳಿದಾಗ, ಸರ್ ಪೀಸ್ ತೆಗೀರಿ, ಅದು ವೆಜ್ ಅಂತ ಹೇಳಿದ್ರು. ಹಾಗಿರುವಾಗ ಶುದ್ಧ ಸಂಪ್ರದಾಯಸ್ಥ ಮ್ಯಾಥಮೆಟಿಷಿಯನ್ ಅಮ್ಮ ಹೇಳಿದ್ರಂತೆ ಹೋಗಬೇಡ ಅಂತ. ನನಗೂ ಹಾಗೆ ಆಗಿತ್ತು. ಆಸ್ಟ್ರೇಲಿಯಕ್ಕೆ ಮೊದಲಿಗೆ ಹೋಗುವಾಗ ಅವ್ರಿಗೆ ಹೆಂಚಿನ ತಿಂಪ ಅಂತ ಕೇಳಿದ್ರು ನನ್ನ ಹತ್ರ ಅಮ್ಮ. ಆ ಒಂದು ವಿಷಯದಲ್ಲಿ ನಾನು ಅವರೊಟ್ಟಿಗೆ ಕಂಪೇರ್ ಮಾಡಬಲ್ಲೆ ಅನ್ನುವಂಥ ಒಂದು ಹೆಮ್ಮೆ ನನಗುಂಟು. ಅದು ಬಿಟ್ಟರೆ ಯಾವುದೇ ವಿಷಯದಲ್ಲಿ ಕಂಪೇರ್ ಖಂಡಿತ ಅಲ್ಲ. ಅತ್ಯಂತ ಅದ್ಭುತವಾದಂತಹ ವ್ಯಕ್ತಿ. ಇಕ್ವೇಶನ್ ಅನ್ನು ಬರೆದಿಟ್ಟು ಎಷ್ಟೋ ಬೇರೆ ಬೇರೆಯವರಿಂದ ಸಾಧಿತವಾದಂತಹ ಪ್ರೂವ್ಡ್ ಥಿಯರಮ್ಸ್ ವೇರ್ ರಿಟರ್ನ್ ಆನ್ ಹಿಸ್ ಓನ್. ನಾನು ಹೇಳಿದೆ 3932 ವರ್ಷದಲ್ಲಿ 3900 ಆದ್ರೆ 92 ಎಷ್ಟು ಲೆಕ್ಕಾಚಾರ ಹಾಕಿ. ದಟ್ ಈಸ್ ಹಿಸ್ ಕೆಪಬಿಲಿಟಿ. ಎಲ್ಲಿವರೆಗೆ ಅಂತಂದ್ರೆ ಹೈಸ್ಕೂಲ್ವರೆಗೆ ಒಳ್ಳೆ ಮಾರ್ಕ್ ಬರ್ತಿತ್ತಂತೆ. ಹೈಸ್ಕೂಲ್ ನಂತರ ಮ್ಯಾಥಮೆಟಿಕ್ಸೇ. Sir is going to talk about mathematics we experience. I think Ramanujan lived with mathematics only. ಅವರಿಗೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಮಾತ್ರ, ಮತ್ತೆಂಥದೂ ಇಲ್ಲ. ಉಳಿದೆಲ್ಲ ಸಬ್ಜೆಕ್ಟ್ ಅನ್ನು ಇಗ್ನೋರ್ ಮಾಡಿದ್ರು. ಹಾಗಾಗಿ ಒಂದು ಡಿಗ್ರಿಯೂ ಇಲ್ಲ. ಆದರೆ ಆಕ್ಸ್ಫರ್ಡ್ ಯೂನಿವರ್ಸಿಟಿಯಿಂದ PhD ಸಿಕ್ಕಿತ್ತು. ನಮ್ಮ ದೇಶದಲ್ಲಂತೂ ಖಂಡಿತ ಸಿಕ್ಕೋದಿಲ್ಲ. ನಮ್ಮಲ್ಲಿ LKG ಪಾಸ್ ಆಗಬೇಕು, 10th ಪಾಸ್ ಆಗಬೇಕು, PUC ಪಾಸ್ ಆಗಬೇಕು, ಡಿಗ್ರಿ ಆಗಬೇಕು, PG ಆಗಬೇಕು, ಆಮೇಲೆ ಆಯ್ತು. ಅದಕ್ಕೆ ಕೋರ್ಸ್ ವರ್ಕ್ ಆಗಬೇಕು ಬೇರೆ. ಇವರ ಜಸ್ಟ್ ರಿಸಲ್ಟ್ ಅನ್ನು ನೋಡಿಕೊಂಡು ಕೊಟ್ಟಂತಹ ಡಿಗ್ರಿ. ಹೆಚ್ಚಿನಂಶ ಅವರ ಬಗ್ಗೆ ನಾನು ಹೇಳಿದೆ, ಹೆಕ್ಕಿದ್ದನ್ನು ಮಾರಿದ್ರೆ ಸಾಕು ಅಂತ. ನೆನಪಲ್ಲಿ ಬಂದದ್ದನ್ನು ಹೇಳಿದ್ದೇನೆ. ಅವರ ನನಗೊಂದು ಹೆಮ್ಮೆ ಇದೆ. ಈ ಡಿಸೆಂಬರ್ 22 ನ್ಯಾಷನಲ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಡೇ ಅಂತ ಘೋಷಣೆ ಮಾಡಿದಂತಹ ಸಂದರ್ಭದಲ್ಲಿ ನಾನಿದ್ದೆ. ದೆಹಲಿ ವಿಶ್ವವಿದ್ಯಾನಿಲಯದಲ್ಲಿ ಅವರ 125ನೇ ಜನ್ಮ ದಿನದ ಸಂದರ್ಭದಲ್ಲಿ ಭಾರತ ಸರ್ಕಾರ ಘೋಷಿಸಿದಂತಹ ಸಂದರ್ಭದಲ್ಲಿ ನಾನು ಆ ಕಾನ್ಫರೆನ್ಸ್ಗೆ ಹೋಗಿದ್ದೆ. ಗೌರ್ಮೆಂಟ್ ನನಗೆ ದುಡ್ಡು ಕೊಟ್ಟಿತ್ತು ಹೋಗಿ ಬರಲಿಕ್ಕೆ. ಆ ಒಂದು ಹೆಮ್ಮೆ ನನಗಿದೆ. ಹೆಚ್ಚಿನ ನಿಮಿಷ ಅವರ ಬಗ್ಗೆ ನಾನು ಇತ್ತೀಚೆಗೆ ಹೋದ ವರ್ಷದ ಸಂದರ್ಭದಲ್ಲಿ ನನಗೊಂದು ಹವ್ಯಾಸ ಉಂಟು. ಏನಾದರೂ ಅವರಿಗೊಂದು ಶುಭಾಶಯವನ್ನು ಸಲ್ಲಿಸುವುದಿದ್ರೆ ಅವರ ರಿಸಲ್ಟ್ ಇಟ್ಕೊಂಡು PhD ಮಾಡ್ಲಿಕ್ಕಂತೂ ನನ್ನಿಂದ ಖಂಡಿತ ಸಾಧ್ಯ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಈಗ ನಾನು ದಾರಿ ತಪ್ಪಿದ ಮಗ, ಅಂದ್ರೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಬಿಟ್ಟು ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ಗೆ ಬಂದವ. ಹಾಗಾಗಿ ಆ ಒಂದು ನೆಲೆಯಲ್ಲಿ ಖಂಡಿತವಾಗಿ ನನ್ನಿಂದ ಸಾಧನೆ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಬಟ್ ಐ ಕ್ಯಾನ್ ಗಿವ್ ಟ್ರಿಬ್ಯೂಟ್ ಟು ದ್ಯಾಟ್ ಫೆಲೋ. ಅಫ್ಕೋರ್ಸ್ ಮ್ಯಾನ್ ಹೂ ನ್ಯೂ ಇನ್ಫಿನಿಟಿಯಿಂದಲೇ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ನಾನು ಬಾನಿಲ್ ಛಂದಸ್ಸಿಗೆ ಒಳಗು ಮಾಡಿಕೊಂಡು ಬರೆದ ಒಂದು ಪದ್ಯವನ್ನು ಹೇಳುತ್ತಾ ನನ್ನ ಮಾತನ್ನು ಮುಗಿಸ್ತೇನೆ. ಅರಿತನಂತವ ನಾಡಿ ಅರಿತು ಅನಂತವ ಆಡಿ ಸಂಖ್ಯಾ ಶರದಿಯಳು. ಮೀನ್ಸ್ ಹಿ ಪ್ಲೇಡ್ ಇನ್ ದ ಓಷನ್ ಆಫ್ ನಂಬರ್ಸ್. ಲೀಲೆಯಲ್ಲಿ ಲೋಕದಿ ಬರಡು ಎನಿಸಿದ ಅಂಕೆ ಸಂಖ್ಯೆಗೂ ಜೀವ ಮೂಡಿಸಿದ. ಮೀನ್ಸ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ನಂಬರ್ ವಾಸ್ ಹಿಸ್ ಲೈಫ್. He gave every feature for every number. For him, not even a single number is useless. ಬೆರಗು ಹುಟ್ಟಿಬ ತೆರದಿ ಗಣಿತವ ಪರಮ ತಪದಲು ಒಲಿಸಿ ಮೆರೆದಿದ ಭಾರತ ದೇಶದ ಹೆಮ್ಮೆ ರಾಮಾನುಜನೇ ನಮನಗಳು. So with this I pay tribute to Srinivasa Ramanujan, and every Indian must be proud about his accomplishments. ಅವರ ಹೆಸರಿನಲ್ಲಿ ನಾವು ರಾಷ್ಟ್ರೀಯ ಗಣಿತ ದಿನವನ್ನು ಆಚರಿಸ್ತಾ ಇದ್ದೇವೆ ಅನ್ನೋದೇ ದೊಡ್ಡ ಹೆಮ್ಮೆ. ಐ ವಿಶ್ ಯು ಆಲ್ ಪೀಪಲ್ belated happy National Mathematics Day. Thank you.
Thank you, sir, for beautifully expressing the importance and relevance of the day and giving tribute to Srinivasa Ramanujan by your own poem. Now, it's time to remember and sharpen our brains by getting some awareness on this day. We will post some questions on the screen. Whoever answers quickly will be given a prize. Preference will be given to students. If students are not able to answer, then the question will be passed on to the faculty members. So, first question is, in which year Indian government declared 22nd December as National Mathematics Day? Those who know the answer, please raise your hands. First preference for students. Any students? Guru Madikila. Anyone? We can guess also. Sir just now told, right? In his speech. Here we know, but he told you regarding the conference. Anyone? No? Nagraj sir. One student. Mic ತಕೊಳ್ಳೋಗು. Which year? 2012. No. Very near. It's not, please read the question carefully. It's not National Mathematics Year, but it should be National Mathematics Day. See the difference. Any faculty members? Answer? If you know the answer, you can answer it. Yes, correct. 2011. So the prize goes to Nagraj sir. I request the chief guest to hand over the prize to Nagraj sir. Thank you, sir. Now next question. While rating mathematician on the basis of pure talent on a scale from 0 to 100, what score did Professor Hardy give to Srinivasa Ramanujan? Anyone? Of the scale from 0 to 100, Hardy gave one scale for him. What is that scale? Number. No, not infinity. 0 to 100. Within that scale you need to tell. Yes, those who know the answer, please raise your hands. Students, first preference for students. 88, no. You know, right? He is a genius. So what the number he will get? 100. So the prize goes to me. Okay, so no one get the prize for this. Okay, next question. Which number was considered as Ramanujan's number? Sir has told in his talk. No. Hardy number. Those who are missing the speech, they can answer it. Yes. Correct, Manjunath sir. So the prize goes to Manjunath sir. 1729. The correct answer is 1729. Thank you, sir. Next question. Who is this greatest Indian mathematician? ಚಾಕ್ಲೇಟ್ ಅಲ್ಲ ಸರ್, ಇದು ಕಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಕೊಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. Okay, so next question. Okay, so if you know the answer, please raise your hands. Which actor played the role of Srinivasa Ramanujan in the movie The Man Who Knew Infinity? Yes, boys. Anyone? No? If you don't answer, then the preference will be given to faculty. No one knows? Recent film. You are googling it. That is not right. Sneha. Yeah, Sneha, this is the correct answer. Dev Patel. Okay, next question. Which of the following, which fellowship was given to Ramanujan? Which fellowship was given to Ramanujan? So there are different fellowships. So which fellowship was given to Ramanujan? Options you require? Okay. What option I can give? Indian Mathematical Society, American Society, Royal Society. Please raise your hands. No mass answering. If you know, please raise your hands. Again, I have given the hint also. No. Only one attempt for the audience. Yeah. Who is that? Yeah. Royal Society. Very good. Thank you, sir. Next question. Okay. Which is the only number whose value is equal to the number of letters in it in English? Yes, sir. 4. Very good. Anand Malya, sir. 4. So 4 has value is also 4 and number of letters are also 4. Next. Fear of numbers is called what? Fear of numbers is called what? Dash. We have different kinds of phobia, right? So which kind of phobia it's called as? Yes, you are very close. Loudly. Anyone knows the answer? Faculty members? Google ಮಾಡಿದ್ಯಾ? Yes, tell. What is that? Tell me that answer. Huh? Arithrophobia. No. Anyone? No one? Any faculty member? No. Okay, next. Numerophobia. Okay, next. The book Lost Notebook belongs to Srinivasa Ramanujan. Okay, next. Last question. Ramanujan's Sato series is extremely useful for evaluating the value of what? Pi. Correct. The answer is correct. So the prize will be given for Dr. Vasudeva sir. He has answered it correctly. ಯಾರು ಹೇಳಿದ್ರು? ಬನ್ನಿ ಪ್ರೀವಿಸ ಕೊಡುವ. ಬನ್ನಿ. Yes, come. Thank you all for your active participation. Now it's my pleasure to introduce today's speaker, Dr. Raghavendra A. Dr. Raghavendra A is presently working as the principal of Purnaprajna College, Udupi. Sir completed his PhD in the field of mathematics in the year 2017 at Dravidam University under the guidance of Dr. Surya Narayana. MSc and MPhil from Mangalore University. He served at St. Aloysius College for 9 years and is currently working at Purnaprajna College for the past 20 years. He has published 4 research articles in reputed journals, presented papers in national and international conferences. He was a resource person for several workshops for PU lecturers and high school teachers. We are all pleased to have you, sir, on this occasion. With this brief introduction, I invite Dr. Raghavendra A. to deliver a talk on mathematics we experience. Over to you, sir.
Good afternoon, everyone. It's more than a talk, it's just a chat, a pep talk. I have prepared for only this occasion, though it is being viewed through YouTube. I'm very happy, I'm very thankful to the management of Sri Madhva Vadiraja College for inviting me here and giving me this opportunity to address you people. Being a mathematics teacher, so I feel very proud to present this on the celebration of National Mathematics Day. I'll begin with where exactly Sir stopped, maybe. That is, I'll follow, my talk will be, we experience mathematics in our day-to-day life many a times. Without our knowledge, we work in our mind lot of mathematics. Okay, now my question here in the beginning for all of you, individual question for you, because answer varies, every answer may be correct, there will be no prize for that. Okay, that is, tell me when exactly you started doing mathematics? At what age? First standard? Before that you never counted? When you were 3 years old? So just see, this is where the foundation of my talk is on. This is where exactly I begin. Sir said about this. The formulae, what Ramanujan has posed, many of them have not been proved, but they are being used. Lot of applications in recent years, very recently, the existence of black hole and the behavior of waves, they were verified using Ramanujan's work. Ramanujan never thought of black hole and invented those formula. Usually we say necessity is the mother of invention, but pure thinking doesn't require any necessity. See, that was the thinking level of Ramanujan. Can we do this? Not maybe at Ramanujan's level, at our individual level. Every one of us has this capacity. We do it. Okay? We don't formulate them. Many a times we formulate them, use them, forget them. Yeah. See, this is a famous story running about gravity was invented when apple fell on Newton's head. But you believe that? Okay, this is how we can narrate the things easily so that you remember and you understand as a common man. But just because an apple dropped from tree, just we ourselves, let us think about it. How did Newton think? There is some force attracting it. So this is how our mind works. Okay. Gravity was theorized because Newton started wondering why the apple fell. Okay. Yeah. Forget about the title now. Dripping water droplets over the ear. We have seen. You might have observed also. Okay. You find some small holes and you leave it for years. You see beautiful carvings in some of the tourist places. Okay. It can even break a huge stone. So do you realize any mathematics in this? We use this particular phenomenon even in our day-to-day life, even in our latest mathematical tools. What is it? Where is mathematics in this? Yeah. So mathematics and philosophy, they go together. We cannot differentiate our thinking and mathematics. Ma'am said about numerophobia. Many of students have fear about mathematics. It was created by the syllabus, maybe by the teachers, by the curriculum. But in fact, none of human being can fear about numbers, or because they cannot live. It is just like you breathe. If you are afraid of, just like now we are closing our face with a mask, okay, we are afraid. So this fear comes because there is some threat. Okay, if you don't feel threat, you don't close your face. So exactly, this fear comes because when you teach mathematics, it is taught like that, or you study because you have to answer in the examination. But it should be experienced. Okay. The ancient philosopher Archimedes, we call it Archimedean principles. One of the principles is about the numbers. X and Y are, see, those days numbers means only positive numbers. Okay, those days numbers means only positive numbers. X and Y are two numbers such that X is greater than Y. How much greater? Any number. Maybe one number is 10, other number is 10 power 200. See, this is such a simple result. Nowadays we find that there is nothing big in that result. Archimedes said, Archimedes said that you add this X, add this Y, very small maybe, several times, go on adding Y plus Y, 2Y plus Y, 3Y plus 4Y plus 5Y. So one particular time you can outnumber X. So that was simple principle he gave. So this is how we state in mathematics. Do we use it? Say if I take I take this pen and I tell you to measure the circumference of this room. Can you? Yeah, you will tell the circumference of this room is about say 10,252 times of this pen. Okay, I ask you to measure circumference of this entire compound, this college compound. Can you? Yes, possible. So same idea what he said. The philosophy is that it is for mainly for students. The sustained effort can reach any task, any goal. Can you climb a mountain if you keep your effort? Yeah. You only require, say after reaching the top, you say that finitely many, maybe 10,000, maybe 50,000, maybe bigger number, but it is finite. As far as number is considered, it is finite. Finitely many steps are enough to conquer this. So my steps were very small. At a time I was covering only 1 feet at a time, but still I can climb. So this experience now relate to Archimedean principle. Are they not the same? See, the first physics rule he posed, they were never differentiated. His mathematics rule came from his thinking level. Same thing he said, that first rule, he thought of this lever, first lever, and he said that, yeah, give me a lever and a place to stand, I will move the earth. However big the weight is, I can lift it, I can move it. What pressure I put is very small, but length of the river, that helps me. That rod, that helps me. See, y is very small, but multiply by L, that will overcome x. See, that physics idea and the first mathematics idea, they are related. Our story, how we can relate, like apple. Apple, what we related to Newton's gravitational force. Tortoise is very optimistic, saying that I too can win. Can it? Yes, it can, it is possible. Yeah, no prize for this. Can any one of you say where this incident from? There is a hint, Ekachakrapura. See, not many mathematicians become poets or authors, not many. Unlike our Vasudev, he is good in both. Mainly because when we go through stories like this, we think some mathematics in it and we forget about the story. So what mathematics is there in that? Anyone who can recollect this figure from? No, I have given the hint there, boy from Ekachakrapura. Figure is something related to that. Ekachakrapura comes in Mahabharata, where Bakasura lived, and the story was he had to feed every day with the food and a person. So it was coming to, understanding in that village, every day one family has to provide. So they have to sacrifice one person from the family. Okay, it came to that house where Pandavas were living, and previous day the three house members, father, mother and boy, were discussing who has to go. So they had a problem. Then the boy says, holding a stick, I will go, I will hit and I will kill Bakasura. It's a very innocent boy. It's an answer because of his innocence. But can he do that? Looking at the previous examples, yeah, it might have. Okay, next. Yeah. See, same idea now we are using. Mathematical induction. You are giving very small knock to the first pack. Sustained effort That is, you keep the distance so that your knock is transferred exactly to the next one, next one, next one, next one, next one. How many such packs you can make it to fall? Any number, 10,000, 20,000? Can there be any limit for that? No. So what is the principle of mathematical induction? Students, you prove some theorems using mathematical induction. How do we prove this? Yeah, first we verify it that result is true for n equal to 1 or n equal to 2, small numbers. Then we prove that there is a sustained effort, induction. Whatever is true for n is also true for n plus 1. So the first knock makes the second one to fall, that makes the third one to fall, that makes the fourth one to fall. So keep and you can knock everything down. Okay. So this is about how Archimedean principle of mathematics, how exactly we think, the mathematics we experience. Now come to some other problems. Yeah. A very famous paradox, many of you may be familiar with this. Just go through that. The barber is a man in town who shaves all those and only those who do not shave themselves. He puts a board outside his, I will shave everyone, those who cannot shave themselves. And in that village, there is a rule saying that those who do not shave, they have to go to that particular shop. Either you shave yourself or you go to that particular shop. That is the rule in the village. And barber says, I will shave those who do not shave for themselves. Now what about barber himself? Can he shave himself? No, because he has to shave only those who cannot shave themselves. So can he live like that? If he cannot shave himself, then he has to shave. Because he has to shave those who cannot shave themselves. So this is exactly, we say, a contradiction. How do you make it into mathematical idea what we use? Next one. That is similar to Russell's paradox. He makes it more mathematically into set theory. A set contains all possible sets in it as proper subset. This is how infinity was thought. I don't say by Ramanujan, I don't know how he imagined infinity. Each one of us can think of infinity in our own way. That depends on our application. Okay? See, it's like barber. Is he a member of that set? Set of people shaved by the barber. Is he a member or not? You cannot answer. If you say yes, wrong. If you say no, wrong. Next one. Yeah. See, I said just now, I said about infinity, how Ramanujan thought about, he is known for man who knew infinity. Okay, you have a book by Robert Carnegie, very nice book, very big volume also, which explains his story, life story, where his mother played very prominent role. So here there is a lodging which has got infinitely many rooms. Okay. Now just think that this lodging is full. A new customer comes. How can you accommodate him? All rooms are full. How will you accommodate him? This is how you have to handle infinity. You number the rooms and say, give an order, person in room number 1 go to person in room number 2, in 2 you go to 3, room number in n you go to n plus 1th room. Room number 1 is now vacant. Room number 100, he will go to 101. 101 is vacant because 101 room is vacated by person, he is moved to room number 102. So room number 1 is vacant now, you can accommodate. One more comes. Can you do that? Yes or no? Okay, now infinitely many customers come. Thinking that this is an Akshaya Patre, just to test this man, infinitely many people come. How will you accommodate them? Now, you pass the order, you note your room number, you just go to double that number. If you are in room number 1, go to 2. If you are in room number 2, go to room number 4. If you are in room number 3, go to room number 6. If you are in room number 4, go to room number 8. Like that. Am I right? Infinitely many rooms are there. So infinity has got that capacity. Okay. It is endless. Next one. Yeah. So now what exactly is mathematics? Okay. As I was beginning said about fear about mathematics, how it comes from, because we think mathematics is addition, multiplication, division, subtraction. Later we say it is some trigonometric functions, then calculus, then integration, differentiation, maybe some numerical methods. So when you confine mathematics into syllabus, it creates phobia actually, it creates fear, it scares you. Now tell me what mathematics is used. We have 8 identically looking balls, 8 of them. Okay, but 7 of them are okay, one of them is different in weight. We don't know, it is fake one. It is almost like the remaining, but only one differs by its weight. Maybe less or maybe more, I don't know. It may be less or maybe more, but you are sure that one is not exactly like the remaining 7. You are given a scale to weigh. Just compare the weights, how many times you have to use the scale to figure out the fake one. Okay? Do you use addition here for this problem? You think your addition knowledge will help you? Your calculator can do this problem? Now I give this problem, you can work out at home, very interesting, it's a teaser you can say. There are various methods, try. What is the answer? If you get the correct answer, you will know that it is correct answer. How exactly? Answer I will give you in minimum 3 ways. 3 times you have to weigh. You can find out the fake one. And also you can say it is weighing less or weighing more. Try this problem. Okay. Now my interest is not in this puzzle. My interest is what mathematics did you use? Or do you use? Many of you might have started thinking about solving this problem. Maybe 4 in one, 4 in another. Will it solve? Yeah, one will go up, one will come down. Immediately you say, I don't know which is the correct one. Is it not? So I put 4 in one scale, 4 in another scale. One goes down, one comes up. Where is the fake one? Here or here? So my first skill effort, weighing effort is waste, of no use. Of no use. I cannot improve my situation. Am I right? You understand? So this is experience. Okay? Experience. So experience tells you how to make your mind work. So mathematics is not restricted to numbers, not restricted to differentiation, integration. Come out of that. It is simple thinking. If you are thinking, then you are doing mathematics. Can you identify me when I come next time after a month or so? Do you use mathematics there? You do. You do use mathematics. Okay, one more puzzle before that. Yeah. See, this was a puzzle went viral because this was asked to high school students. It was in Singapore Mathematical Olympiad, like Indian Mathematical Olympiad, one of the problems for Singapore Mathematical Olympiad. Just read this. The way in which this question is framed, that itself should be admired. Cheryl's birthday is one of the following: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 options, not just 3 or 4 options, 12 options. Okay? Cheryl tells the month to Albert. She doesn't tell what is her birthday. She just tells this is particular month, my birthday. Then she tells the day, in which date, okay, to Bernard. Now, okay, next. As soon as she tells the month and she tells the date to Bernard, immediately Albert says, I do not know the date because she told me only the month. But I am sure that Bernard also doesn't know. See, he came to the conclusion immediately, only having the knowledge that which month, he came to the conclusion, the other man doesn't know the day. Looking at his comment, listening to his comment, other one takes that as a data. This is how exactly datas are condensed. It's a very, very huge profiteering area in computer science. Okay? I didn't know at first. Now, as soon as Albert makes his comment, now I know. Now I know. When Bernard says so, immediately Albert's reply is, okay, you have come to know, then I also know. Then I also know. So, again, this is a problem. If you don't surf internet, students, you find the answer, I know, but you try yourself. Okay? See, this is a pure mathematics problem. So, what mathematics do you use here? This is where logic plays a role. Most of our thinking, most of them, they start with 0 and 1, yes or no. Answers are yes or no. Even the previous problem, I said scale and 8 bars. Okay, you give a trial, answer is yes or no. If the no, then again second trial, yes or no. Again third trial, yes or no. Done with the answer. So this is how we use binary numbers. Yes or no, 0 or 1. Even here, it is same. That is because it is purely logic. So logic is based on thinking. So thinking, logic means immediately foundation for set theory. If yes, it belongs to the set. If no, it doesn't belong to the set. Next. So when is my birthday? She asks. Next one. Okay. This is one more problem, very simple problem. This problem I have posed here just to say that how we can think properly with the given data. Most of the time in the previous problem also you find it is not possible. Data is not sufficient. Problem is not correct. Okay. So look at this problem. A person dies leaving a bounty of 291 diamonds to his sons. Share them equally. Now question is, how many diamonds each one will get? If I ask this one, immediately I will get a question back. How many children he has? I am not telling that. Then your question is wrong. Isn't it? Yes or no? See, there are hidden data here, So these data need not be told. This is where we go wrong, producing huge data. You think logically, most of the data can be condensed. Shall I pose the same question in a simple manner? He leaves, say, 15 diamonds. He leaves 15 diamonds. How many will each of his son will get? Come on. Yes. 5 or 3. If he has 5 children, he will get 3. If he has 3 children, they will get 5. Am I right? Yes or no? So now you are able to answer. At least partial answer. You are not able to identify that number 291. It is a product of 2 primes. It is 97 into 3. Both are prime numbers. Okay. Now one more data is hidden. That is our thinking says he is not Dhritarashtra to have 100 children. So he cannot have 97 sons. Must be he is having only 3 sons. So each one will get 97. See, we come to the conclusion exact answer because of the situation. So that situation also provides some data. Many times that will be a flaw also. When we construct algorithms, write programs, we take up certain situations. They are framework, our mind framework. We are working in certain framework. We are sitting in certain environment. Okay. So looking at this audience, I talk something, but there are audience outside this hall. They are out of my mind, so I am not addressing them. So I may say something against their interest, may. So I have to keep in mind those audience are also there. I have to address them also. Same way. So sometimes it may go wrong, but most of the time, yes. So he had 3 children, each one will get 97. So this is just an example where thinking process can improve solving the problems. Next one. Yes. So this is the question I asked. Can you recognize me after 1 month? You may say yes or no. Now, most of us have faced this problem. If you look at a few Chinese people coming, can you identify them? Same problem will come if many of us go to China. They can't identify us. If you see a herd of buffaloes, I won't say cows, cows have different colors maybe, buffaloes, we find it very difficult to identify. How will owner identify? How will a Chinese identify another man in his group? How we identify ourselves here? Any mathematics here? We have very latest tools. What you are using? Yes. So they are all tools, MATLAB, matrices. There you are trying to convert the data into numbers, into system. I'm just telling you about thinking process. Yeah, image processing is an application. Exactly, image processing is an application. You have to use matrices, you have to use MATLAB. Image processing depends on what? Have you seen cartoon of Gandhiji, but just two lines, one stick and one head like this. So just by two curves, we identify Mahatma Gandhiji. Am I right? So how exactly our mind works? Rest of the things you are able to imagine. Rest of the things, that data is enough for me. So likewise, if I constantly talk to you people like this, you will be able to identify me. Even after 1 month if I come, you will be able to identify me. That is, there are some common data, that is to identify a person, which we convert into junks. I don't require this, I don't require this, I don't require this. Okay? They are all becoming zero. So I stand at now my new zero. In my new zero, most of those unwanted data are zeros. They have no place. So I have got exactly few things which I can recognize. Next, previous. See, our brain has capacity to set average features apart, look at minor differences. Okay? So when we compare, we look at the differences. Do we use this in mathematics? One simple example. Okay? Yeah, next one. Yeah, look at this integration. If you have forgotten, I can't help. Okay? Very simple integration. The first integration, it looks very difficult. But we use the method of substitution, what we call substitution. We take x square plus 1 equal to t, then that will be converted to second integration. Immediately you give the answer. So we were not able to identify the first one. That was our problem with the Chinese people. But if you go to China, live there for 1 month, so you have to go to, x has to go, t has to come. So now it is t. It is not Indian, it is Chinese. Or if it is not Chinese, he is an Indian. He has come here. He is staying here for 1 month. He will be recognizing all of us. So this is our substitution method. This is, may not be knowing many a times, unknowingly we are using. This is nothing but change of coordinate system. From x coordinate, we are moving to a new coordinate. What happens here is, usually our x and y coordinates are like this, perpendicular. Why do we use this perpendicular coordinate system? To identify a point, identify a curve, then see what is the figure is, solve the problem. Why should x and y be always straight lines? No need. They are simple ones to use. You change x to something like this. X axis will be like this. Then a curve like this will be a parallel line. It is not a curve. It is a straight line. So this is what is happening here. So substitution method, what you are using is putting some unwanted data into junk, making it look simple and identify. This is this particular problem for integration. See, this was identified from Mars, and when Sir said about Ramanujan's imagination, he was familiar with numbers. Every number he was giving its own characteristic properties. We are not able to do it. Okay? Many of you might have seen the movie Beautiful Mind. Okay, that was Nash. He's a mathematician. Usually mathematics people, they don't get Nobel Prize, but Nash got, not for mathematics, for his work in economics. He's a mathematician originally. So he did a lot of work in economics using mathematics. His idea of mathematics, he went off his mind. He was under treatment because of his thinking. Even in the sky he was able to see the figures. You constantly look at the sky, you will find the designs. You will find the designs, the stars form. Yeah, this is exactly how our mind works. Okay, this is exactly, maybe I think Ramanujan was thinking about numbers. Till his era, see, he had formal education, he had some textbooks, he had some previous knowledge. The mathematics has been developed, you can think of from civilization. Okay. How it has been developed? Did they have formal mathematics? Now we see, without mathematics you cannot use physics, you cannot use chemistry, you cannot use electronics, you cannot use computer science. Then how did they live? Okay. Just a brief history, I will go through this very quickly. Okay. History, how in India or maybe entire world also you can think of, it was about the collected historical data. I won't say this is the beginning point. Mathematics in ancient India from 2300 BC to 1700 BC. So those days you have seen Mohenjo-daro excavation, you find beautiful cities. Now it is getting excavated. People now wondering how did they manage those geometrical shapes for those figures. See, without having the knowledge of constructing right angle triangle, you cannot construct those. So how did they construct right angle triangle? Did they have the knowledge of Pythagoras theorem? Pythagoras only formalized as a mathematics subject, but that was being used. There were techniques to use. Pythagorean triplets, what we call now, there were techniques to use. Okay, to get exactly, perfectly right angle. It should be right angle, just not trial and error method. If you do trial and error method, by the time I reach some 50 feet, it will be off the line. But it was not the case. Now they find it is perfect. Even now people go wrong, but those days they didn't. So they had the knowledge of constructing right angles, knowledge of constructing circles. So they had good enough mathematics, but none of them were scripted and preserved. Okay, some plates are available. They are all containing not numbers, some figures, flowers, some trees. They have to be deciphered, not done successfully. These scripts are not, they are not deciphered. Okay. Then comes 2000 BC to 800 BC. We call this is Veda Kala in our history. At that time, the Veda means not generated, Vedas are not generated, they have got no origin, we say. They were formulated, just like we have syllabus, have textbooks. Those textbooks are not the origins, they are just streamlining what we know. Okay, something like that. So the Vedas were formulated. So that era, in those era, that is a period in history, we had mathematics developed and we have got some definite proofs. The numbers, you find how they were represented. So these are all having with the proofs. Okay, next one. So next. So I'll go through very quickly. You have got several articles available in internet on this. Okay. big numbers. Then coming to see properties of geometrical shapes. Katyayana, he has given a shloka about right angle triangle. So next one. So he explains the proof of that. Sum of the two areas is equal to third area. He gives proof like that. This is the one where they had the method of converting area of circle into area of a square. Not exactly, approximately equal. Otherwise it may not be possible. Irrational equal rational it will become, not possible. Next one. See, we have, this was also developed then. It is now called as Pascal's triangle. They were using it as a Meru. Meru, we have seen Meru Parvata. So it's like a mountain. Then in 600 BC to 300 BC we have proofs of using pi, value of pi. They were approximating as root 10. It was approximate value, root 10 equal to pi. So Ramanujan gave several such results to find out values of pi exactly up to several number of decimal places. Okay. Recently that physicist Kaku, he says the series representation by Ramanujan, they are exactly the models for the very complex theory of waves. Some 24 models they have developed, all using Ramanujan's theory. So that was the imagination he had. Okay. So you will find applications later. Those applications, okay, they are verified. Is it possible? Is it theoretically correct? Will it work always? Using his work. Then the era of Buddhists and Jains. Those days for rituals they were using geometrical shapes, numbers. So all these are existing. Indices law. Next one. Then combinations, what we find very difficult subject in mathematics, combination. Okay. They were being used, selection from given number, source and allocation problem you can say nowadays. Then age of epics, which we have just before history, we have solid proofs. Then Siddhantas, where we have text available now, though we do not know who wrote it. Those texts they contain. Next one. One of the Siddhanta, very famous, even now being used, is Surya Siddhanta, a very good book for early astronomical studies. Astronomy was a main necessity for learning the mathematics in those days. After construction, that is for construction they were using mathematics. Rituals, one of the wonderful invention is calendar. That is nothing but mathematics. Why do you say I am 50 years old or I am 60 years old? Age is calculated. Days are calculated using calendar. So calendar is framed. You require a calendar. Okay. So time is measured. Okay. It is used along x-axis. Now you say x-axis. But thinking was same. Time as a base, they measured the movement. They measured the movement of astronomical planets taking on x-axis time. Next one. Now this is the recent years. Okay. We say Aryabhatta invented zero, but actually we find in his work that he has given the use of zero, prominent results he has given. Okay, what is 0 exactly, but it was being used earlier also. You will find many cases. You have got several shlokas which you can now say it is nothing but property of zeros. So they were all, see, this is my all talk is based on, they were all their experience. They experienced mathematics. They never formulated theory or formula for that. They used it. They used it. It was understood by their common sense. A person using it agreed because he also agreed it is common sense. It was working well. Yeah, this is where exactly Ramanujan's work begins. Series 1 square, 2 square, 3 square. We have a formula n into n plus 1 to n plus 1 by 6. We study it. We use induction to prove that. Okay. We have very simple method of proving it for small number. See, if you join those such 6 series, one is area with the n. Say one top one is 1 square. Bottom one is 2 square area. Okay, all of them have height is 1. Therefore, what is the volume? 2 square. Third one has got height 1. What is the volume? 3 square. What is the total volume of that one pyramid? 1 square plus 2 square plus 3 square plus n square. Total volume. Okay, if you add, join them, you can successfully join them and form this parallelepiped, this box. And if you measure length and breadth, length will be n, breadth will be n plus 1, then height will be 2n plus 1. 6 of them have been joined. So what is the volume of 1 divided by 6? That is our formula. So these formulae, now we use it, we prove them, but originally how thought process has helped to generate the formula. See, Ramanujan has given more than 3,900 formulae, we say. Maybe how many years he might have worked for 10 years. So that means per year 390 formulae. Every day he was giving 1 or 2. Okay. He never checked, as hardly rightly put. They must be true, because otherwise you would not have been able to imagine that. Hardly gave him 100 marks. Himself he gave 25 marks in that scale. So I am just 1/4 of what Ramanujan is, because he was able to discuss with him. And in those days, there was a very great mathematician, Hilbert. We have Hilbert space. Hilbert, and Hardy gave him 80 marks. Yeah, these are all our Indian mathematicians who have done their work and preserved. We get their text available. Lot of mathematics, lot of latest formula, most of them are in geometry, trigonometry. Trigonometry we study with the sine, cosine, okay, but they were studied as a measure of circle. Now, just to end, just to stop, root 4. Many a times we write plus or minus 2. That is wrong. It is only plus 2. Why not minus 2? And you may get angry with me also, or you may say what you are saying is wrong. Root 4 is plus or minus 2. So this is again going to thinking process. That's why I have given this example. In a number line system, you have got all the numbers. Okay, you got all the numbers. Give me a number. Okay, give me a number. When you square it, will give me 4. So you say answer 2 or minus 2. So 1, 2 here, 1 minus 2. When you square it, okay, this is 2, this is minus 2. Okay, give me a number which will give me, when you square it, which will give me 5. One more number should give, because other side there should be one more. What is that number? So there is one number, definitely there is one number. I have to give some name for that. And its counterpart minus number should be also there. It should be there, it is a property. So you give a number, give that number a name, and it is not the only number. What about 3, 7, 11, 14? Many of them. How many names you go on giving? Alpha, beta, gamma, delta, that will get exhausted. So we again use infinite property to number them, to name them. It is only square root, one symbol. Then it is giving answer 4, so I am giving root 4. It is giving answer 5, therefore root 5. So there are two such numbers. One is root 5, its counterpart is minus root 5. Yeah, again I have to end where Sir has said. He said he is a Dari Tappida Maga, jumped from mathematics to computer science. These 3 people are also like him. He is also genius like them. Again, see these people, see how mathematics is a passion we develop. The 2 of them, Neeraj Kayal and Nitin Saxena, in maybe 2002 or 2005, they represented India in their mathematical Olympiad. They were originally mathematicians. Okay? Because of their natural talent, they were able to solve the so-called tough JEE Advanced. Those days it was IIT JEE exam. They were able to clear that exam, and like others folk, they entered one of the IITs. Fortunately, to their fortune, they entered IIT Kanpur. They found equally good caliber in Professor Agarwal, and they were computer science students, and because of their natural interest, they wanted some project in mathematics. They approached Agarwal, and looking at their talent, he gave them some work, and 3 of them, they produced what is called as AKS algorithm. A for Agarwal, K for Kayal, S for Saxena. And it is one of the very prominent results in number theory in recent years. You can Google the name AKS algorithm and you will know the prominence of that. And they are computer science graduates. Both of them are working in computer science field as mathematicians. So the original passion remains. Okay, I think Neeraj Kayal and Agarwal are still in Kanpur as professors. Saxena is in Microsoft as a research fellow, professor doing research in mathematics. And Agarwal has received Padma Shri Award. All of them, they received Shanti Swarup Bhatnagar Award, highest award for scientific research in India. So this example I have given just to say that how your passion for mathematics, or for that matter any subject you learn, okay, can still bind you to the same subject even though your work, your job may be different. So come to conclusion, the day-to-day mathematics, what we experience, okay, use it to learn any subject. Maybe you are a physics student, chemistry student, computer science student, maybe you are a good cook at home. Even there you can use your mathematical thinking to make it better. Thank you.
For giving a wonderful talk. All of us have gained a lot of knowledge from this amazing presentation. Now I request Dean Quality Assurance Dr. Sudarshan Rao to offer a memento to Dr. Raghavendra A as a token of our appreciation. Thank you, sirs. The essence of all beautiful art is gratitude. I would like to thank the management, principal, vice principal, deans and SW of SMVITM for rendering the support in conducting the program. I would like to thank the resource person Dr. Raghavendra A for readily accepting our invitation and gracing the occasion. I also thank Atul sir for accompanying sir. My sincere thanks goes to Dr. Vasudeva, Dean Research and Consultancy for the introductory remarks. Our heartfelt thanks goes to PREC Director Dr. K.V. Rao for sponsoring this joint venture. Also, we appreciate the helping hand of Mr. Ashok Kamath, Vice Principal, Diet Udupi, and Mr. Stanley Tauro, President of Karnataka State High School Assistant Teacher Association, for helping us to reach out the science and maths teachers of Dakshina Kannada and Udupi district. Also, our sincere thanks to Mr. Deepak Rao, Senior Assistant Professor, Department of Computer Science, and the maintenance team for live streaming the event. Also, I thank Mr. Anantesh Rao and Mrs. Chitrakala for making the banner and flyer for the event. Finally, I thank the HOD Dr. Lalita Priya Castellino and faculty members of Mathematics